Hi, my name is Avinash Vatani, and today, as a part of Standard Deviants Group in Math 1318 course Time Series Analysis at RMIT University, we are going to present time based forecast on overseas visits using historical data from 1980 until 2020. The data has been sourced from the official website of UK, which is ons.gov.uk, and is present at the Leisure and Tourism section of the portal. The above data represents the overseas visits in UK from 1980 until 2009. The counts are in thousand units. So looking at the time series plot, the graph shows that the count of overseas visits to UK is seasonal in nature, and there were about 4.1 million visits in August 2019, and this is primarily due to the environmental conditions in UK, which were the temperatures where the temperatures are highest between June and August, and the environment is the most pleasant in April and September. While because of the cold weather conditions, the number of visits seem to decline by year end, which is pretty much apparent from this graph. Now let's look at some of the characteristics of this plot. The plot here shows some minor changing variance where we can see that some of the fluctuations takes place among across the years. Also, it shows is pretty much seasonal in nature, as this is the monthly data. So the graph shows the seasonality, and we also didn't seem to see any intervention points in the series, like there are no major dips and there are no major peaks in the series. And the last is the data has a linear trend, which is pretty much seen from this blue line in the graph, where the data seems to follow a forward moving trend, an increasing trend. Now, through careful evaluation of this problem, we have finalized that the stochastic based modeling would be best for this data set. That is, the trend is not expected to be the same in the future, and we've already seen an example for this, which is the current COVID issue, which has led to the decline in the count of overseas visits to UK. So we can expect that the next trend in the series would not follow the same pattern. So we can use the stochastic based trend models in order to model and forecast this data set. Here I would like to draw your attention that we are primarily aimed at forecasting this series based on the past data, and does not take into account other factors including pandemics such as COVID-19. Now let's look at the model specifications. So here we are primarily following the residual approach in order to model this series, and based on the ACFs and the PACFs and the ESCF plot of this series, we have obtained few candidate models, which includes the in multiplicative models, such as our seasonal, the combination of our seasonal and our ARIMA based models. So here we have used only the middle numbers like 1 1 1 across all these points, shows that we have used the seasonal differencing, which was necessary to take to handle the seasonality in the nature, without which we weren't able to use our stochastic trend models. Now, for the ordinary trend, we have used single differencing, and the ordinary trend was pretty much able to handle all the seasonality of the data, apart from handling the change in the mean trend. Also, so based on this, we have finalized approx 9 candidate models. However, the top 6 models didn't have the exact white noise nature in which we were interested among their residuals. So we have to reject these 6 models, and based on the ESCF plot, then we obtained some higher models, such as the one we looked at here would be the AR component 1 and the MA component 4, and then the AR component 0 and MA component 7, and then the AR component 1 and MA component 7 likewise. So from this analysis, we have finalized the last 3 models, Now, looking at the parameter estimation, we have just looked over the parameters of these three finalized models, where we were to able to see that the higher orders, here MA4, here MS7, and here MS7 was significant. So we are not pretty much concerned about the lower order significance, because here they were insignificant. So from here we can move forward with all these three models without rejecting any one of them, because what we are interested in the significance nature of the seasonality and the higher order MA and AR component, which we have observed from these three models. So looking at the residual analysis of all these three models, we can see that they follow the exact same nature, like the white noise series of the ACA plots of their standardized residuals, and the normality nature of their residuals, which is pretty much apparent from these histograms and these QQ plots from this series. Further, the Lin-Jon box also shows that the lags are pretty much uncorrelated. So we can move forward with the residual analysis with these models. So the final selection was based on the AIC score, through which we were able to finalize SARIMA 017 and 011. So the blue line in the forecast series shows that the our forecasted model was pretty much able to capture the mean trend and the seasonal trend as well. Also, the overseas visit here shown is expected to reach 34 million by 2020. So finally, we were able to finalize the models through the AIC score analysis. Now, the last thing to note here, that the coronavirus pandemic, however, has an unavoidable impact on the travel, and the final results of which are not yet seen. Thank you.